So I think we can start. Good afternoon. I'm Hannah Halaburda. I'm chairing this session. I'm also one of the speakers later on. Just heads up, the third speaker for our session is not here. We knew about it well in advance, so he's going to connect remotely. We're going to test the technology. He's going to make a presentation without being here. So there will be a little bit of fiddling between the second and third presentation with technology. Before then, our first speaker is Cathy Barrera from Prism Group, and off to you. Thank you.
Thank you. Thank you. Okay. All right, so I'm Dr. Cathy Barrera. I am a PhD-trained economist, and I'm going to talk to you today about incentives, generally speaking. We are going to talk about at a very high level findings from economics from several different fields of economics. So since we're going to be covering so much ground in microeconomics, we're not going to be able to really dig super deep in our 20 minutes, unfortunately. But I'm one of the co-founders of Prism Group. Prism Group is an economic consulting firm in the blockchain space. We work with both startups and enterprise, helping design incentives and market mechanisms for these blockchain platforms that are being launched. We also do some of our own research and present at various places, and we've been involved in some educational activities, whether that's working with fine institutions like MIT or sort of doing on-location education for startups and portfolio companies of VCs. So blockchain and economics. As an economist, the thing that drew me to the space, that got me interested in this technology, is the understanding the technology as encoding economic systems, encoding economies or encoding markets into a protocol that allow buyers and sellers, peers, to interact with one another and to exchange value. So blockchain requires both an understanding of economics and an understanding of computer science in order to build these effective systems. And what I have found, what we have found at Prism, is that the teams that are building these amazing new platforms, this amazing new technology, tend to have very, very deep expertise on the computer science side. And we hope to help bring some more expertise on the economic side. So what is the big difference between the way computer scientists might approach thinking about a blockchain or distributed computing system versus the way an economist might think about it? Economics is the study of individual choice and strategic interaction. So when economists think about these systems, they're always thinking about the people who are setting up the servers, setting up the computers, running the software. What choices are those people making? What resources are they choosing to contribute? And how are they interacting with other participants on the platform? Whereas the computer scientists might be a little bit more focused on the machinery, on the software, on things that can be programmed or can be controlled. So as an economist, what we're thinking about is how you arrive at an equilibrium result in terms of the behavior, which is something you can't control, but you can nudge or you can push in the direction you want by designing incentives, by designing the economic part of the system. So again, since we only have 20 minutes, I'm not going to be able to go into too much detail about what you need to know about incentives in order to design an effective blockchain platform. But I will cover two big ideas. So one is that smart contracts, which are the blockchain version of what we call formal contracts in incentives, are just one way that you can provide incentives to participants. That's just one way to modify or nudge the behavior in the direction that you want to. And in fact, smart contracts or formal contracts, those two terms are not interchangeable, but they're smart contracts are a subset of formal contracts, are are limited. So they aren't going to get you across the finish line. They aren't going to solve the behavior that you would like to see on your platform. And there's many ways in which this type of formal contract-based incentive can go very wrong. So we'll talk about that a little bit. In the second part of the talk, I will go into a framework that we developed at Prism Group that puts together the different areas of economics, the different fields of economics that can all contribute to incentive design. So again, this isn't necessarily just something like pay for performance or a formal contract where you say, if you do behavior X, then you will receive reward Y. We can also have different types of mechanisms that will push behavior in the direction we'd like to go. So very briefly, I just want to give my definition of incentive. So an incentive is a mechanism that's chosen by someone, by a person or a group. So it's not gravity. It's not the cost of pulling ore out of the ground. Those aren't things that we chose. It's the price that you put on a resource or a good. It's the contract that you write with an employee or with a supplier. So it's a choice variable. It's something someone chose. And what it does is it changes the costs and benefits of different actions in order to move those actions in the direction that the chooser, the designer, wants those actions to go. All right, so starting with, hello, we have our third speaker, I think. Okay, starting with the limits of smart or formal contracts. So we all know that incentives have pre-existed blockchain by many years, millennia perhaps, and the study of incentives has been rigorous within the field of economics for decades. So I'm going to start with an example that's non-blockchain based. You may have heard of the scandal that happened at Wells Fargo. Some people there tried to design an incentive scheme to get their branch employees to open more accounts to generate more business for the bank. That incentive was designed very, very badly, and it resulted in quite costly litigation for the firm. I think that this example is also particularly interesting because while the bank got in big trouble for deceiving its customers, the accounts that were opened fraudulently didn't necessarily injure the customers. Most of those accounts sort of sat dormant, didn't incur any fees. They didn't do anything at all. The only thing they did was cost the bank in terms of the compensation that they had to pay to their branch employees. So this is a situation of pure gaming where those branch employees wanted to drive up the performance metric that was being used in order to gain money for themselves, to gain benefit for themselves. But they were neither helping nor hurting the bank in terms of the activities the bank was looking for. Ultimately, though, the government wanted to intervene here. So the point I want to make here, Wells Fargo is one of the oldest banks in the United States. They have an insane quantity of resources, right? They are able to settle $575 million suit here. They can figure out how to get the right expertise in the door so that they don't have these kinds of problems. They can figure out how to hire someone who can design incentives well, and they still fail, right? So designing incentives is incredibly difficult. It doesn't just happen by accident. You really need to have a thorough understanding of economics, of the field of contract theory and other related fields in order to do this right. So moving on to a blockchain-based example, I will call out Bitcoin. So what I want to highlight here is that, again, the design of the system, the incentives that are chosen, that are put in place by whoever is building this blockchain platform. In this case, we don't know, but those systems are designed or put in place with some goals in mind, right? We want to achieve some behavior of the folks who are going to participate in this system. Now, there were a variety of goals that Satoshi Nakamoto outlined in the original Bitcoin paper, and those things included it being a peer-to-peer system and sort of having this distributed control, right? Now, the design of the system did succeed on some of the goals that were outlined there, but it didn't succeed on others. So while we might say that the incentives were provided for security, that worked well, the incentives for distributed control did not work as intended, right? And so perhaps we can bring some of what we know from economics, from these fields of incentive design, in order to do a better job of getting to the goals that we actually intended. So here's a list of common pay for performance problems. So these all come out of the literature in the field of contract theory. There's, again, decades of research that has already been done on all of these issues and how they arise in different contexts. But these are the really well-known ones and the ones that they sort of come up in different combinations in different contexts. So you can read about them here, and I think the whole presentation is going to be available, so I won't go through in too much detail, but what I will say is that the reason why these formal incentives often fail to get us where we want to go is because it's very difficult to measure what it is that the behavior that we intend to occur. It's very difficult to give the incentive on exactly the thing that we want to happen. And that it was true for both of the examples that I already mentioned, right? So Wells Fargo wanted to have its branch employees open accounts that actual new consumers were using, either brand new customers to the bank or customers that existed but hadn't previously been using the bank in that way. So cross-selling new revenue streams. That's the outcome that they wanted, but it's actually very hard to provide an incentive on that outcome. So instead, they provided an incentive on the number of accounts that were opened. And similarly for Bitcoin, how can you measure whether the individual miners are achieving distributed control? You can't. So instead, what's measured is the amount of hash power that goes in. There's a tournament-style incentive system that's used in order to reward those coming to the platform. That gains adoption, that gains security, but it doesn't necessarily gain one of the goals that we're trying to achieve, which is distribution. All right. One of the reasons why formal contracts are so limited in being able to achieve the kind of behavior that we want to achieve is that contracts are incomplete. So this middle point is the one that I just mentioned. This is just it's a constraint that you have as the designer of a system, and contracts can also be incomplete for these other two reasons. One, we just might not be able to think of every contingency. We might not be able to think of every possible attack. We might not be able to think of every way that the system might be gamed. And so we should anticipate, we should expect that there will be unintended consequences, that there will be gaming type of behavior. And we need to be able to design our systems so that we can adapt to those eventualities. And I think that that's one direction that that the research in the blockchain space needs to go. We need to be able to adapt to gaming behavior over time rather than trying to anticipate every possible consequence. All right. How am I doing on time? Great. Okay. All right. So I'd like to introduce our this is our house framework for economic design. And I'll go through it really quickly, but we're going to focus in on the middle layer: contract design, market design, and information systems. So when you build a blockchain platform, you have to start with an idea of, what is the market that you're trying to build? What are peers coming to this network in order to transact over? What kind of resources are you hoping that different participants will bring? With Bitcoin, it's hash power. We see a lot of platforms that are looking to create peer-to-peer marketplaces over computing resources, for example. We even see platforms that are trying to create marketplaces for real-world goods. It could really be anything, but you have to start with, what is the value proposition? What is the use case? What is the strategy? Then, once you understand that, you can start to think about how are we going to build these layers in order to achieve what we're hoping to achieve here. So obviously, in order to build anything, you need to be able to raise some money, raise the resources so that you can do that. And then the very next thing that you need to do is think about, how are we going to design this marketplace? How are we going to design the interaction between these peers, between these buyers and sellers, so that it will function in a way that everyone wants to come to the platform? They want to bring the resources you intend for them to bring, and they want to behave in a value-producing way. They want to actually provide the service that buyers are coming to buy. They want to act not necessarily honestly, but they want to act in a way that is profit maximizing or maximizing their individual objectives that then also provides value to the other participants in the system. So this layer, contract design, market design, and information systems, is our incentive stack. Now, I already talked a little bit about contract design, about formal contracts, pay for performance. That's one way that we can provide incentives to the participants. But you'll see that there's these two other columns here that are supporting the house. So one is market design. That's thinking about, how do buyers and sellers find each other in this marketplace? If I'm a buyer and I'm hoping to procure resources, how can I find the person who has the correct resources that I want to get, and ensure that they're someone I can rely upon to get those services? Not necessarily trusted, but I can trust in the marketplace that the person I'm transacting with will provide me what I expect. And finally, information systems. So there is a field of economics called the economics of information that looks at how different types of information being available to market participants has an impact on their behavior. So within blockchain systems, we can think about what information is provided to the participants that can allow them to get to the kinds of outcomes that they would like to get to. And again, all three of these pillars are going to provide us with the best incentives we can get to in order to ensure that that the participants are getting what they hope for out of the system. So I'm going to gloss over my non-blockchain example, but eBay uses all three of these pillars in order to provide both buyers and sellers on the platform with assurances and make it a productive and perceived as useful marketplace. So you have dispute resolution, you have sort of contract design that involves these intermediaries. Of course, I'm not suggesting you necessarily need that specifically for blockchain, but they've thought extensively about contract design. They have search, and they have ordered search. So more reputable or sellers who have performed well in the past get a priority on search pages. And they also have, of course, actual reputation in terms of ratings and a rating system where buyers and sellers can leave feedback for each other. eBay, incidentally, has an entire team of economists who help design all of these things in order to make sure that the platform functions as well as possible. So the blockchain example that I'll use here is storage. You might have heard of them. This is a platform marketplace where peers can buy or rent and lease computer storage from one another. So incidentally, Storage has just launched their third version of their network. This is a quote that appears in on their blog describing the launch of the third version. And what they're highlighting here is that in their second version, they were able to achieve some of their goals, but they weren't able to achieve all of the goals that they set, and in particular, the behavior of the service providers, the behavior of those nodes providing storage wasn't to the standard that they were hoping to achieve. They didn't get the durability and performance that they were hoping to get. And if you read through their white paper for the third version of the platform, you'd see that they pull all three of these levers that we're talking about. So they rethink how their smart contracts are going to work. They rethink on what occasions are those nodes paid. So for example, in version 2, nodes were paid on egress when they receive a file to store or a piece of a file to store. And in version 3, nodes don't get paid on egress. They only get paid when they have an audit and when they return the piece of the file. They're also thinking about market design. How do users find nodes, and how are nodes connected with another type of participant on the platform. And finally, they also think about information systems. So they worked on designing a formal reputation system where different observable performance factors can be combined in order to determine a reputational score that can be used in sort of the market design and the market matching piece. So this robust market design, this robust incentive design that involves all three of those pillars is not reserved only for centralized players. It's also important for any blockchain platform that wants to deliver on the promises it's making in terms of the performance of individuals who they can't control, right? Individuals who are peers coming to the platform, they can't be fired, they can't be told what to do. Instead, we need to provide them the incentives in order to ensure that we get the behavior we want. So this is just a slide summarizing the three types of incentives that I just discussed. And I'm out of time, but in the discussion, I'm happy to answer any questions that you all have. And thank you. My contact information is here.